Друзья, доброе утро. Мы продолжаем наш ПГДИ. У нас остался третий день. Судя по количеству людей, не все дожили до третьего дня. Вот. Пятница, так сказать, сказывается. Но я надеюсь, что коллеги будут подтягиваться потихоньку, ну а мы будем начинать, поскольку у нас регламент, график и все такое. Два организационных объявления. Объявление номер один – это по поводу наших футболок, которые мы разыгрывали в течение предыдущего месяца по промокоду. У нас несколько было победителей, было несколько людей, которые привели людей по промокоду, вы должны получить футболку, но никто до сих пор этим делом не озадачился. Поэтому, если вдруг кто должен получить футболку, подойдите к Марии в какое-то удобное время на ресепшн, и вы получите причитающуюся вам уникальную футболку. Это момент номер один. Момент номер два связан с тем, что мы, напоминаю, разыгрываем слона специального, который привез Магнус к нам. И для этого нам нужно постить в Инстаграм, в Твиттер, еще куда-нибудь с хэштегом ПГД15. Так что напоминаю, что конкурс продолжается до сегодняшнего вечера. Постите фотки, твиты и так далее. И вечером мы будем подводить итог. И на заключительном мероприятии, на конференции, мы уже как-то, как сказал Илья, крайне субъективно выберем победителя и вручим слона. Вот. Ну и переходим тогда уже непосредственно к нашему докладу. У нас сегодня открывает день потрясающий докладчик Флавио, человек, который долгое время он родился и жил в Бразилии, и в Бразилии он трудился в open-source компании, которая занимается внедрением бесплатных технологий в различные бизнесы, в различные государственные структуры и так далее и тому подобное. И он расскажет про совершенно интересный кейс о том, как вообще бесплатные технологии, open-source технологии используются на уровне крупных банковских учреждений, на уровне крупного бизнеса, и как это все происходит в Бразилии, как они внедряли инфраструктуру в крупнейший бразильский банк, и как это все работает на Postgres. Поэтому, друзья, давайте поприветствуем Флавио.
Well, good morning, everyone. I'm sorry I don't speak Russian, so it will have to be in English. Well, as I think that Roman has presented me, I'm Flavio. I come from Brazil, and I'm going to talk to you about the using of Postgres in public institutions in Brazil. Actually, this presentation has been given in PGCon 2010, so it's a 5-year-old subject. But I have added some more information after that, and it's not the same presentation. So, a bit about me. I'm Brazilian. Actually, today I'm living in France, and I decided to move there with my family. I am an electronics engineer. I'm not a computer scientist from the university, but as an electronic engineer, we learn a lot about computers, so that's why I'm in love with them. I work with databases after 1995, so I'm 20 years old DBA, and I started using Postgres in 1999, so there's a long time ago. It's not a CV here, I'm not looking for a job in Russia, but I have to say to you that I was working at 4 Linux free software solutions. Today they're called open software specialists. And the story I'm going to talk to you, it's their use case. I was authorized by them to talk to you. And today I work at Miracle. It's another company in France, and we use Postgres there also. That's why I work there. But the story I'm going to tell you is for Linux history. Just to put you in the timeline of free software in Brazil, how the things started over there. I think it's about the same here in Russia. You are starting to have laws and rulings to how to use open software or open source software in your country. So over there, everything started in the state of Paraná. It's one of the Brazilian regions, and they are really the good state to start it up. They have good technology guys over there. And in 2003, they put a law that said we have to use open source software in our institutions, in the state. After that, the state of São Paulo, in the São Paulo's University, the largest university in Latin America, they started the Free Software Center that is known for its large servers and to have good bandwidth. When you talk about free software, you have to have good servers and nice internet connection. At the time, they were the best ones. In 2008, the same state of Paraná put standards for ODF usage in the government state. And in 2008, the country followed the state of Paraná and they started to use ODF standards too. And in the end of 2008, all the country had laws and rulings to use free software all around the country, especially in the federal institutions. And then Postgres arrives in a public bank. The bank, in case, is called Caixa. Caixa is the name of a box in Brazil. This bank is the second public bank of Brazil, and every Brazilian citizen has some kind of relationship with the bank. Every social benefits, every kind of help that the government does to its citizens has to use the Caixa systems. So everything is very big. Brazil is a 200 million people country. It's not as large as Russia, but it's the 5th country in the world in terms of population. So everything is very, very big. So the system that I'm talking about is an OLTP system to make the ATMs to work. The ATMs is the automatic machine that you can take money. But in Brazil, in the case of the Caixa Bank, you can have a regular bank account to take our money, and you can also use the ATMs for the social benefits. That's why the system is very important for all the countries. It's not just about banking and money and so on. Everything that a citizen needs, it has to go to a Caixa Bank and to a Caixa ATM to handle its stuff. When you look at the transaction count, 750 TPS, it doesn't look like a lot for today's standards. We have today's systems that does, if you take Facebook, Twitter, Google, they handle hundreds of thousands of transactions per second. But everything is distributed. It's not a non-LTP database. And when I talk about 750 transactions, I'm talking about banking transactions. These are not database transactions. In the database, we have a lot more transactions per second. And this is a very complicated system. The important thing here is to keep the response time in 1.5 seconds for the system, not for the database. The database usually is in the order of milliseconds. We have an application, and this application has to process things too. The database is not so large. We are talking about 250 gigabytes. It's not a big database, but for an OLTP system, it's very complicated. And evidently, it has to be highly available. This is the most important thing in a system like that. You just have to work, always. As I said, there are 3 systems in the same environment. The second one is the OLAP system to monitor the ATMs. So the first system handles the transactions. Everything that you do in the ATM goes to that system and back. And the second system has to monitor if the ATM works. The ATM is in the street, is inside the bank agency, is in an airport, is in a hospital, is everywhere, and you have to monitor them. The ATM, it has lots of sensors to inform the system if everything works. If it has money in the cassette, if it wasn't stolen, if it wasn't jailbroke, for example. and the ATM sends this information to the OLAP system that has a 1.5 terabyte database. That's huge. I have heard of 20 terabytes database in Postgres, but it was not me. For me, it's the largest one I have touched. And we have a third system that is OLTP2, but it's very small. It's just to handle messaging, SMS. When you use your bank, you can receive in your cell phone this, an SMS saying, okay, you have borrowed money, something like that. It's not so complicated that I won't talk about it. Just to have an idea how the system works, in the right side you see the map of Brazil with all its states. When I talked about the state of Paraná, do I have a point device here? I don't know.
Should be.
I don't know. Well, I can point it out. The state that started everything in free software in the country is this one. The third from below up. And so the ATMs all around the country. When I was working there, there were 22,000 ATMs. Today, I have heard they have 30,000 ATMs all around the country. So all ATMs connect to a CSN, it's a Cisco load balancer, and to a Java application in JBoss servers. Actually, it's a cluster of JBoss servers. Those JBoss servers are connected to a PostgreSQL database, and they are connected to a mainframe. Actually, the corporate system of the bank is in the mainframe. It's written in COBOL. Yes, it exists. Even today, lots of banks use it. And what is the rule of Postgres here? What it has to do? Postgres controls the life of the transaction. For example, if you want to take money in the ATM, you put your card, then you choose how much money you want, and the transaction starts. When you put your password, your code, your PIN, the first leg of the transaction is the communication from the ATM requesting the transaction to the JBoss servers. And when the JBoss server receives from the ATM the request, it has to put it on the database. So this is where Postgres starts its job. It's actually is an insert, one-line insert in a table. And the JBoss server sends to the mainframe the request. So if everything goes well, the same transaction is logged in a Postgres table, and the mainframe has received the request. If for somehow some problem in the mainframe, the request is not handled, it's registered in the Postgres database. It's very important to have it in a banking system. Everything has to be synchronous. Since the communication between the JBoss servers and the IBM mainframe is not synchronous, I have to register that in a Postgres database that is synchronous. Well, this is the first leg, the request. When the mainframe replies the request saying, okay, this client has money, you can give money to him, it's the second leg, is the reply from the mainframe to the JBoss server, and the JBoss server has to register it in a database. So an update in the same line that was inserted in the first leg is done in Postgres database. This is the second leg. The reply is sent to the ATM, and the ATM can give the money to the customer. Other problems can arise. For example, there's no money in the cassette deck, and the ATM can't give money to the customer. So here comes the third leg. The ATM has to send back what happened at the end. The transaction was completed successfully or not. The money has been given, or the ATM had a problem, loss of energy, for example, loss of money, out of money. So the third leg is the third update in the Postgres table saying this transaction was completed or not. Everything has to be logged And we have actually two main tables in the database. One table that has one line for transaction. Each transaction is a line, insert and two updates. And we have a second table that is the log, the transaction history. The insert, the update, and the second update, they are logged separately in this table. So we have all legs logged in the table. Evidently, we have lots of other tables to control everything, but the two main tables do this. When I said that we have to really register everything we do, I just can't lose what's in there. So there is a site replication that at the time was done by storage replication with fiber optics. And it's not in the same site. We have another site that is 4 kilometers apart from the main site, and everything has to be synchronous. So when an insert and update, everything happens here, it has to be synchronously replicated over there. At the time, it was Postgres 8.3. We hadn't Postgres replication yet. So we had to use some kind of hardware application to have everything working and in a high availability fashion. And then the problems start to arrive. The first one, the first challenge, is the hardware and operating system choice. When we are talking about a public institution, and this public institution is a bank, everything is regulated by internal rulings. They have rulings for everything. They have a book of rulings this side, and everything was chosen by the rulings, not by the technical choice. For example, the storage system that was used to start the thing, if you just can't throw a system like that for all the ATMs in the country. You start from like 100 ATMs, we start to use the system. But they gave to the technical staff, they gave one storage that was borrowed from another project that had ended. And this storage was one storage for documents. Who here has worked with storages? Can he raise the hand, please?
Yeah.
You. And so you know that one storage for documents is not optimal for databases. They are formatted differently, they have slow disks, they have a different cache size, they have different processors, so it's not optimal for a database. And with, like, from the 22,000 ATMs, about 1,000 ATM, I started to have problems of performance. The storage wasn't capable to handle all the transactions I needed. And the second storage they gave me, when I said this storage is not possible to work with that, they gave us the final storage that was in the project, and that wasn't optimal either. So it's very complicated to work with a thing that was designed to failure. The other thing I say you to just run away if you see that is the storage Tetris. Tetris, I know that's well known in Russia, but the storage Tetris is, you have a storage, you have 10 terabytes of disks available, you start to put systems in the same storage to use this available space in the storage. But the problem for managers is that they don't know that storage is not a bag of data. Storage is all about performance. So if you start to throw every system you have in the same storage that you have another database working, you will surely start to have problems of performance. So you need to manage that. You have to put your systems in a storage, you need to know where your data is. And the operating system choice was not open source at the time. It was just before the release of Open Indiana. And just 1 year before, Oracle has bought Sun. So they used Solaris for every system in the bank that was not in the mainframe. Other systems were Solaris systems. And it was not open source. And I am an open source advocate, I am an open source specialist, and I am an open source passionate. So I start to work with Solaris. If you know how to work with open source, you have always some difficulties to start to use something that is not open. And another thing, in Solaris, they made a choice by recommendation of Sun at the time to put the system in a ZFS file system. And nobody knows it at the time. So how to handle that? The second challenge is people. People know Oracle. If you go to a bank, everybody knows Oracle. Everybody. And everybody trusts Oracle. Because Oracle is good. Oracle is heavy. Oracle is strong. Oracle handles transactions. Oracle does everything. And they are afraid of change. Everybody is afraid of change. So you have, with a system that's not proprietary, it's not Oracle, and it's completely different, everybody's afraid. And you start to have bullying in the data center. Ha! Here comes the open source consultant with their talk. And the DBAs especially, they are very conservative. As a DBA, I can say I am conservative. I don't like to change things in a radical fashion. I like to change things slowly, one thing at a time, study, and then suddenly you have to a bunch of Oracle DBAs and you put Postgres over that. Just doesn't work. And at the time, PostgreSQL, it was mostly unknown. People doesn't know how to spell, how to speak. Postgre, I have heard everything. And the high management of the bank, that known Oracle Araque, you know that well, I think, is the sad, multi-master, scalable database, the best in the world, and you sell it very well. The marketing guys are very good at selling that. But Postgres doesn't do that. How do you scale out Postgres in the system? What they don't know is that Oracle Araque does not scale out in OLTP. If you know someone that said that scaled out an OLTP system with Oracle Araque, it wasn't optimal. He wasn't using Oracle properly. Well, the third challenge, it was the application. It was a Java application. At the time, Java was already in use by companies, so it was not really a problem to use Java as the language. But the problem is that the company that did the application, they ported from Oracle. The application was written from Oracle and Cache. Anyone knows Cache database? It's very rare. And since the system was written for another database system, it was not optimal for Postgres, obviously. And the developers, they had bad habits. I don't like to fight against developers. I prefer to work with them. Usually DBAs fight against. It doesn't work for me. But they had some bad habits, especially because the same system was used to smaller banks. So when you come, especially when you come from the companies that hadn't worked with Caixa, the bank, the public bank yet, they had worked with another bank. For example, they had worked with a bank that had, I think, 100,000 customers. It's not a lot. And the system worked well. So they were always complaining, but the system works in the other bank, why it doesn't work here? But it's not the same scale. So, I have the fourth challenge, is to address the real challenges. All the other challenges that I was talking about, they were political, decisional, and the real challenge is PostgreSQL tuning. You have to tune it well to work. The operating system tuning, even if it's not open source, you have to tune it. Hardware tuning is the hardest. And to give answer to support tickets. I was the consultant, so I was answering questions for everybody. Okay, so after the challenges and problems, I would like to talk about what I did to win, to realize that it will be okay, it will work. The first point is to start with a multidisciplinary support team. I was the PostgreSQL consultant, but I had kernel specialists, Linux specialists, operating system specialists, hardware specialists, storage specialists, everybody in the team. Without that, you can't go on. When you talk about a database, the database uses the system for everything, especially Postgres. We rely on the Linux kernel, for example. We rely on the Solaris kernel. So when Postgres make a request to operating system, the operating system has to handle it well. After that, you have to put a backup strategy in place. It was in the first week I started working that they hadn't a good backup strategy. They made dumps every day. 10 in the morning, they had a dump. Just don't work. So we put in place the dump strategy every week, for example, and the PITR strategy. I hope everybody here does it. If you don't know how to do it, it's better starting. And the PITR backups, the wall logs, the base backup, you have to put it in disks. You don't have to put it in tape. It makes no sense. You have to restore easily and quickly if you need it. In case of disaster, you need to have this backup accessible in a disk. And please, not in the same disk as the database. I put it in another partition. No, it's not in the same disk. You put it in another disk, and if possible, far away from the server. And the dumps have to be stored in tape for long-term storage. The dumps is a thing that you have to have it for a month, for years. And you have to replicate everything. If you have one copy of your database, you're doing it wrong. You need to have one backup in the data center, another backup outside. Sometimes, in the old days, in this case, they used fiber optics to replicate, but I know today people that carry tapes in a car to another place. And it's always not enough to say backup everything. Okay? One thing that mostly is not done from people is to test the recoverability. You have to test if your backup works. You can recover from a backup. Have you tested it? If you didn't, start doing it. I know lots of people, but I had a backup, and when they started to try to recover, after an incident, evidently, it wasn't capable to do that. So test your recoverability, it's important. Even if you can trust Postgres PG dump, you can trust PITR, you can't trust your procedures, for example. You know how to do that. Oh, I have PG barman. Have you tested it? Sometimes not well installed. Test it. And test again in a regular fashion. Do it every month, every 6 months, but do it regularly. The second step, after having all the policies in place for backup, is starting to turn Postgres. Things that are very important to turn, I think everybody has told here in the conference. I wasn't here yesterday, but I'm sure people told you to turn shared buffers properly, turn workman properly, turn the number of connections. This is one of the most important things for performance. Don't have lots of connections in the database. Just don't do it. I know people that has put, I know horror histories of people that has put 3,000 connections in a database. It just don't work, doesn't work. You have to control, especially in an OLTP system, the maximum number of connections come from the number of cores you have, CPU cores, maximum 2 times that number. So those machines, they had at the time 32 cores. The maximum number of connections is around 64. And sometimes it's a lot. So you have to turn in. But the application is needing more connections. You have to use a pool. In the case of Java applications in JBoss, the pool is inside the application server. So you have to turn it properly. You don't need to turn Postgres for that. You have to turn your application. If your application doesn't have a pool, you can use PG Bouncer. It works very well. But you have to control the number of connections to the database. This is the most important thing for performance. I have done lots of testing of them. The number of checkpoints, but when I say checkpoints, it's all the parameters of checkpoints. Checkpoint segments, checkpoint completion target, everything you have to turn. You have to put evidently more segments. Start from 50, go to 100 if you need. You have to monitor. You can log checkpoints and see if you have, during the day, if you have checkpoints starting regularly and not by missing segments. So it's easy to log it in Postgres, and it's easy to change it and just reload the configuration file. You don't need to restart the database, so it's easy to do. There are PG writer parameters. This is interesting. I don't know many people that turn PG writer. The PG writer is the background process that writes in the disk between checkpoints. You can turn it. If you monitor your disks, especially if you have pgxlog separated from the main disk, you can see writes between checkpoints. And you can increase the numbers of the PG writer parameters. So you can start to write a little more between checkpoints, then you can profit from the disk performance. Your disk is capable of writing between checkpoints, so let's do it. It's good for some milliseconds of better performance. The sync method, everybody here knows that in Linux today we use fdatasync. At the time it was OpenSync. I don't remember anymore, but you have to turn it well. If you use Solaris, it was another thing that I just don't remember. But every operating system, you can test it. There is a tool in the config that you can use to that. You can test the timings of fsyncs, so you have to use the better method. And everything that touches buffers, wall buffers, temp buffers, you have to increase the numbers. And one thing that has a lot of history for me is the auto vacuum. I know lots of people that like to turn it off. Please don't do it. Never do it. If you don't know what you're doing, don't turn it off. This is not one thing that you can turn it off for performance. You will always lose. Always. You turn it off, you will see that one operation works better. All the rest will not work anymore. You will start to have problems with planning because auto vacuum is responsible to analyze your database live. So if your database is a live environment, it changes every time. If you don't analyze it in a regular fashion, and auto vacuum does it, you start to have problems with execution plan. And I have received orders from the management to turn auto vacuum off. One day I said to a guy, but why you need to do that? Because when it comes, the performance slows down. I said, okay, we have to turn it. No, we have to turn it off. Okay, I had to do that because it was an order. Yes, sir. It was the worst nightmare in my life. I spent about 2 months of daily vacuums in the night because of that. So never turn it off. If you know what you're doing, you have to study again. You can turn it well. You can make it a bit more smooth with auto vacuum, vacuum cost delay, and vacuum cost limits, you can turn it to not use all the disk performance at the time. And today, at the time it was 8.3. It was the version where auto vacuum started to work a bit well. In 8.4 it got very good, and the responsible was over there, in the room. But you can turn it well. One thing that's special, auto vacuum takes care of transactional wraparound. If you don't know, Postgres has an internal counter for transactions that is 32-bit. Okay, that makes 4 billion possibilities. I will never get there. Oh yes, you will. In this system there, every 5 days you have a wraparound. So auto vacuum takes care of it, you don't need to pay attention. If you don't auto vacuum regularly, one day you will have a freeze. One table that you can't write anymore because it's frozen. It can wrap around. Okay, things that you can turn in the operating system. For all operating systems, you have to turn in the queue of the card for send storage. If you have storage application network, the fiber optics that connect your servers to the storage, you have to turn in the size of the queue. It's not an easy task. Usually you have to improve the values, but it got a lot bigger, you have to decrease, so you have to test. You have to put your database in stress, you have to increase the value, reduce the value, and you have to find the good performance compromise. You have to have multipath. Multipath is to use more than one fiber to connect your server to the network. And with multipath you can double the bandwidth, and you can have a backup if one fiber gets broken or someone just disconnected by accident. With multipath you don't stop your server. If you're using Solaris, there is one mount option that's called Force Direct I/O. In UFS you have to use it so your fsync will work correctly. And if you have ZFS, you have to limit the ARC cache. The ARC cache is one beast that they put inside Solaris, and in FreeBSD too, if you use ZFS, that can use all available memory in the server, which is nice for caching. If you have spare memory, why not use it for caching? The problem is when this cache uses all the memory, it froze, I said froze, the system completely. It stops the file system. You can't write anymore. And Postgres demands an fsync. I won't write. The cache is full. So it does a garbage collection, and it takes sometimes 5 seconds. And 5 seconds in an OLTP system that does 750 transactions per second, it's a lot of time. So you have to limit it. There's an option for that. You just have to limit before the limit of your spare RAM. And if you have Solaris, you need to have vendor support. It's not open source. You don't have all the documentation in the web. You don't have discussion forums. You don't have discussion lists. You need vendor support. Have it. Pay for it. It's worth. I don't like to. I'm an open source guy. I don't like paying for support. I don't like paying for vendors. I don't like vendor lock-in. But in this case, if you don't have another option, do it. If you have Linux as your server, you have to pay attention to linux.conf. You need to increase the number of open files for Postgres. It will use it. If possible, use XFS as a file system. Ext4 is okay. It's getting better, but it has problems of new arrivals. So XFS is a proven guide, and it gets better every day. But Flavio, I like another file system. Okay, it's your choice. For me, I recommend XFS. Use a proven supported kernel version. What I want to say with that, if you use your distribution, if you use Red Hat, you use CentOS, you need to use their kernel. Don't try to compile your kernel. Use the supported version. It works very well. Attention, we are having problems with Debian Jessie. We are having performance problems. There is a discussion from the last year in the international list. You can take a look. They are talking about the discussions inside the kernel team, the Linux kernel team, to have some help from the Postgres community. So be aware that the Debian kernel today is not doing well, especially for reads. Sorry. And you may need kernel performance experts in your team, as I said in the first slide. So after all of that, we are going to talk about queries. But the first time the presentation, we are in the 20th slide, I'm going to talk about queries. Usually we start tuning the things by the queries. It's not true. You may need to partition tables. Don't start to partition tables at the first glance. You look at the database, you have a performance problem, okay, I will partition that. No, it's not like this. When I say intelligently, in a system like that, there are tables that you have to do a huge delete. For example, if you have transactions for every day, in the end of the week, you can throw away the week before. If you do a delete in a table with 1 billion records, but Flavio, you can't truncate the table. No, you can't. If it's the table for the transactions, you can't just truncate. But I can do it in the night. The system is 24 hours, 7 days a week. You can't just stop in the night to make your truncate to start in the other day. So, if you partition a table like that, for example, you have one partition for every week. In the other week, you just can drop the table. You don't need to truncate, you don't need to put a 1 billion row delete. That takes a lot of time. So this is one intelligent fashion of partitioning tables. It's not for performance here, it's for maintenance. It's easier to keep a system like that if you have large important tables partitioned. That's what I call intelligently. And you may need to index your data in advanced ways. It's not just create index. You need to use, to work with developers to know which queries you have and to put indexes for more than one column, or to make functional indexes. For example, sometimes the developers use functions in the where clause. So if you put the same function in an index, you have the index created with the function. So the query will work better. So learn how to index intelligently. You may need to destroy indexes, and it's true, you will. Find index that are not used in the application. You have one view that's called pg.io user index. You can see indexes that are not used, so you can drop them. But Flavio, it's a unique index. Okay, this index you will not drop. But indexes that are just thought for performance, they are not being used, you can drop it. It just costs you in the rights. You will work with developers. You won't fight against them. You don't say the developers are in the other room, they are doing their job, I'm doing my job at DBA, as a DBA. You will work with them. You will never work alone in this kind of system. And please, hibernate. It got better in the last version, but not good. I can say it got less worse in the latest version. When I look at queries with underscores everywhere, the alias authentication, Okay, so you have to work with that. Hibernate is there, developers love it, and sometimes you cannot control the developers to say to them to use Juke, for example, that is a great framework for querying your database. So they will use Hibernate. It's easier for them. Don't let Hibernate generate the schema. If Hibernate has generated the schema automatically, you will have problems. It is your fault. It's not the developer's fault. You set the schema, you look at that, you don't understand that, if you put that in production, it's your fault. Don't let them. But, okay, you're fired if you do that. I will use that schema. Okay, better be fired than use the Hibernate generated schema. So, but you're radical. I said I'm conservative. Control the version of the schema. When the application is changed, you change some tables, some structures, have a versioning system for that, to control that. You need to know what is in our database. And, of course, you have some night shifts. I use it to say that I slept with my shoes on. The phone rang, I had to take my car and go to the customer. It takes some time to get used to that, but it works. Okay, so maintenance. Flavio, had you need to re-index? Yes, I had to, but it's not in a scheduled fashion. You don't put it in the cron tab, I will re-index that. No, it doesn't work like that. You need to understand what bloat is. You need to understand if your index or your tables are getting bloated. If auto vacuum is not working very well, you will need to vacuum full or to re-index some indexes. Just learn what bloat is, understand the MVCC model of Postgres, and make your re-indexes and your vacuum fulls when needed. Usually it's not needed. Usually the database takes care of it, but in some hardcore systems like that, it happens. And it was a 3 at the time. We have improved it a little bit that in the recent Postgres versions. To the end, you will need to provide training sessions. Take that bunch of Oracle DBAs, put them in a room, and make some training sessions. Explain them what are the differences between Postgres and Oracle. Usually, when they start to understand what Postgres do, they start to love it. Especially PSQL. Oracle DBAs love PSQL. Because SQL++ is just input text, enter, query, done. PSQL has lots of functions, it's very nice. You need to know Postgres limits. Right? What can we do with Postgres? What we can't do with Postgres, you have to learn it. And you have to shout out loud. When I say shout, it's not screaming, but you have to spread what Postgres does well. You can do that. And understand that the other DBMSs are not the same. You can't make comparisons between Oracle and Postgres and SQL Server and MySQL. Every database system has its strong points, and actually Postgres has it all. Think Postgres. Don't try to think, I was an Oracle DBA, I did that way in Oracle, I can do that the same way in Postgres. No, you have to think Postgres. So you need to make things the way Postgres wants it. Avoid comparisons and conflicts. Don't try to fight back. And why I say that? Because the other database systems have sale points. They have marketing teams. In Postgres, in the community, we don't have marketing. We have one guy that's responsible for that, Dave Fetter, that he writes the Postgres weekly news. That's the only marketing we have. And in every new version, we try to control what is in the newspapers, what is in the specialized sites, but we don't have a marketing guy that goes there, okay, you have to write that in your magazine. So since we don't have that, try not to have conflicts with other people. You lose. And some strong points that we can talk about, and the things that I learned in the system, is that Postgres can keep a very high TPS. If your disk is capable of writing, and if your kernel is not buggy, you can write very fast with Postgres. The MVCC model of Postgres, we have auto vacuum, we have the need for vacuum, but otherwise, the MVCC model is just strong. It works very well. Transaction isolation is perfect. When I say perfect, it's really perfect. We don't have problems with transaction isolation in Postgres. To commit, the same thing for the MVCC model, the commits are always fast. You say commit, it's committed. If your server is not overloaded, you have some spare CPU cycles, you say commit, it's committed. It's a microsecond thing. We never lost data in this project. This is one of the strongest points in Postgres. It's very reliable. The documentation is extensive. We have 4,000 pages of official documentation. You have lots of books available. They're not expensive. You can buy it. So you have this community. You have conferences that are not expensive. So you have everything you need in your hands. You don't need to pay for certification, for very expensive certifications with official trainings. You don't need that. We have great support companies. I know I worked for Linux. We supported the community. We supported the conferences in Brazil. We supported people traveling all around. I know people from Enterprise DB, they are all in the community. All the developers are in the community. We have here the example, Henrique Lainacangas. He's a community guy. We have Alvaro. We have every company, second credit. We have in every company, we have people in the community. This is very, very nice. We don't have one single company that controls it all. Enterprise DB is not Postgres. It's not the only one. It's not like Oracle is MySQL today. So that's good. We have Fujitsu, we have Enterprise DB, we have Second Credit, we have lots of companies around there. Dalibo. The things are solved quickly. When I say this, I say that the community is responsive. If you ask a question in the forum, or if you ask a question in the chat, it's very quickly. They reply in minutes, sometimes seconds, your question. And you, as a consultant, since you have all the documentation available, you can solve your problems easily, usually. When you go to the community, you have a really, really good point to discuss. And definitely, everything is a lot cheaper than in the proprietary options. And evidently, some needs in the core Postgres were present in the project. For example, some things, remember that it was a tree. There are things that are addressed. Scaling out a no LTP system is very, very hard. All databases have problems with that. It's not just Postgres, but they made comparisons with Oracle Araque that doesn't really scale out a no LTP system. One thing that Postgres is doing better in the recent versions is the caching. How to monitor your cache. What do I have in the cache? What tables, what indexes are in the cache? At the time, there was PG FinCore that gave us the possibility to look the Linux cache, to know what is in the Linux cache. Today we have some more functions to that. It's getting better. The maintenance routines use low resources. You do a reindex, you use one CPU. If you have 40, so the machine does nothing, and your reindex takes a lot of time. So this is one thing that we can maybe improve in the future versions. Today we are working, the community is working in the parallel query. I think in 2 or 3 versions we will try to have something like multi-core reindex. This is being discussed. The SQL administration is a bit hard, especially when you need to look at catalogs. They are not so clear. The documentation is there. If you read the documentation, you can understand that, but you don't have graphical tools to just take your catalog and show up, okay, you have a problem here, you can look around there. For example, I had problems with disk writes. I needed to use one Linux tool to find my problem, but Postgres maybe will be capable of doing that. When I do an fsync, I have a performance spike. What are doing wrong? Maybe we can do that in Postgres in the future. One thing that's very complicated is to audit the database. Especially in a bank, you need to know what people are doing in the database. You have lots of users. You have the application that's connected to the database, but you have your users, and they are doing sometimes funny, sometimes ugly, sometimes dangerous stuff in the database. How to audit that? You have account numbers, you have the money of people over there. So how to audit? I can log all the DDLs. Okay, but how can I log some updates, for example, in a filtered fashion? It's not so easy. It's getting better. We have today some event triggers that we can use for that. And the parallel query is addressed in 9.5. It's coming. So, in the end, Postgres is running. It does the job very well. The people is usually happy. They come to me and say, okay, how it works. You are a great consultant. Everybody here is trying to understand how it works. And people especially loves PSQL. Postgres evolves fast. Every new version, we have lots of new things. And usually, in the past, we use it to follow the other alternatives. Today, Postgres is the guy that does the thing first. For example, JSON-B. We didn't have that. In the other database, Oracle has implemented JSON, I think in 2012. More recently than Postgres. And the community is great. You are here, the conference is great. I know people all around the world, and they are all nice. That's really great. Well, I would like to thank you for your time, for hearing my English, and to thank Ronan that invited me to be here, and to thank for Linux that allowed me to show you this case. It's very nice. Thank you so much. I don't know how much time we have for questions, if we have some. Hey, there's a microphone.
I'm not sure if I understand correctly. You have chosen Postgres because of laws of Brazilian state bank should use open source? Or?
No, the rules from the government was to use open source. Postgres was a technical choice at the time. It was the only one that was capable to compete with Oracle.
Thank you.
In terms of functionality.
Thanks, Flavio. It is very impressive case, very interesting. Some slides ago, along this phrase, data was never lost in the bank project. My question about an incident. If you can, in some word, maybe this broken your NDA, do you have did you face it with some incident that forced you to change a replica or some data restored from wall?
If I understand well, you were asking if I had to use the replica or to recover from a backup.
Yes, in the production.
I never had to switch to the replica. The data center was very reliable, never had a loss of energy, and never had... one time we had one server that had hardware problems, and we needed to turn, but it was easier to turn it off, to attach the disks to a new server and start it again. It was easier than to go to the replica. That was in another building. You have to put all the traffic over there, so it's a bit complicated to do that. But I had to restore one backup. But it was not Postgres' fault. It was one administrator that didn't know Postgres, and they thought that the table files were log files. And then he compressed the data, the Postgres data files, live. The database was running, and in that case we had to restart from the backup.
What's the role of IBM mainframe?
I didn't understand, sorry.
In use
The role?
in use him, I see IBM mainframe. What is the role?
Okay. So, actually, all the banking information is in the mainframe. The rule of this application that I was talking about is to control the transactions, but the account information of the customers, everything is in the mainframe. So when you make a money request in the ATM, this system has to ask to the mainframe.
Not the data storage. No data storage on
Postgres. No, in IBM, all the data is stored there. This Postgres database, all that it does is to log and control transactions. It's a kind of second audit system.
I see. Thank you.
Thank you, sir.
Okay. So your system now runs on Solaris, right?
No, today is running Linux.
In Linux.
At the time of the implementation, it was Solaris.
And
Today is running Linux, and the last time I talked to them, it was 2013. It was Postgres 9.1. They had migrated.
Okay. And what you told about Debian, and what kernel you could recommend?
Today I'm having problems with Debian kernels, and I had a discussion with Magnus Hagener yesterday, and we are really having some problems, but in very high transaction rate databases. I'm having no problem with CentOS.
I see.
CentOS 6, the 6 series, 6.5, 6.6, I don't know exactly what version, we're not having these problems. But with the latest version of Debian, it's a bit complicated. I think they will get addressed very quickly, but I don't know when.
Stable version, okay.
The latest stable Debian is problematic for us. But it's just some performance for reading, not for writing.
If to speak about host IBM, did you think about to move some accounts of bank to the Postgres too? Not only as monitoring, but as a bank application itself. Is it possible?
Banks usually are very conservative, and they are still using COBOL and DB2 databases. I don't know any bank that uses Postgres for the account information. But inside this bank, there are at least 20 systems that are using Postgres today. And they are moving every system at a time, so it works very well, but usually not the banking account systems. I know that there is a system like this for the human cache, for the people that is over there to assist you. There is a system like this that's doing that. That does the same thing, but for the real cache, for the real cashier, for the real time, for the people that when you enter the agency, there is someone that does the thing for you. There's a system like this doing that with Postgres. I think we're done. Thank you.